Hello everyone, my name is Han and welcome to my channel. Today we look at some coins that use zero knowledge proof in one way or another. Let's start with what ZK proof can do. First of all, we need to know that functions have the same expressive power than programs. Basically what I'm saying here is that if you have a program that can do anything, so the program has to be, there's one condition, the program has to be deterministic, meaning that given if you execute the same program with the same inputs, it would have the same result. So if you have that condition, it can be turned into a function. So for example, if you have a program that processes financial transactions, so that the program that Bitcoin executes in order to track account balances, you can also rewrite it as a function that takes the previous balances, the current account balances, the set of transactions, and return the new balances. So you can write it as f of inputs equal outputs. So pretty straightforward. In the context of zero knowledge proofs, some of the inputs are going to be public, but some of them are going to be private, and outputs are public. So what you're saying here is that you know a set of inputs, and you are the only person who knows these inputs, such as the equation f of inputs, both secret and public, equal outputs. So again, for example, if we take the example of financial transactions, what you're having there is that you have f being a function that takes the account balances, the transactions. These are the public inputs. And then the secret inputs would be your secret keys in order to authorize these transactions. And the outputs would be the new account balances. The functions is sometimes called a statement. Because basically what you're saying is that you're stating that this statement function of input equal outputs is true. So previously we talked about smart contracts, which, as a reminder, smart contracts is a program that is executed by all the network in a cryptocurrency. So famously the first smart contract coin is Ethereum, and it gained a lot of popularity over the years, especially because of DeFi. And as a result, the number of transactions on the Ethereum blockchain has grown significantly. With the growth of transactions, because there's an inherent capacity limit, and we have reached that capacity. Now in order to enter the blockchain, you have to pay a higher transaction fee than before. It's got to a point where it's not really economical anymore to directly execute all transactions, DeFi transactions, directly on the blockchain, Ethereum blockchain. And that Ethereum blockchain is typically called layer 1. So a few teams have been working hard on reducing the stress or the strain on the blockchain on layer 1 by transmitting and executing transactions off-chain, and the network that they use for that is typically called layer 2, just in opposition to layer 1. So they have basically a parallel network, so a network where they send and settle transactions peer-to-peer. But in order to have the validation of the real contract on layer 1, there has to be some communication between layer 2 and layer 1. And that communication is basically reporting the end result of a batch of transactions. But because they were all made without the knowledge of the Ethereum blockchain, the question is, how do you believe that these transactions really happen? And that's where this zero knowledge proof enter. Even though you don't have to provide all the transaction history, and you just give the final result, you can prove that these transactions did happen and were properly signed by using a zero knowledge proof. There are a few teams working on these kind of solutions, and they are in general called layer 2 zero knowledge rollups. So I have some names for you: ZK Sync, Aztec, and Starkware. These are 3 of them, and there are more. So the idea is that you have a normal contract rollup deployed in Ethereum, which main purpose is to verify the validity of the zero knowledge proof that is then submitted as a normal transaction to that contract. And along with that zero knowledge proof, of course, you also have the end result of a bunch of transactions that happen on layer 2. Another application of zero knowledge proofs are privacy coins. So privacy coins such as Zcash, Monero, or Cairo hide the information of the transaction using encryption or using other cryptographic primitives. So the idea is that even though transactions happen, you will not know the amount that was exchanged, and you will not know the recipient. Sometimes you don't even know how many recipients you have. So the entire thing could be hidden from the chain analysis. Some coins, such as Monero, mixes the real sender among decoys, and other uses direct encryption. Cha-Cha-20 is the case for Zcash. In any case, because the transaction itself is not clear, is hidden, there must be a proof that the data, the original data, still abides by the rules of a transaction. That, for instance, the transaction is not generating coins. The output value must be lower than the input value. The person who made the transaction has the authority to spend these coins. So typically that means that he has the secret key that is associated with the source account. Another also very interesting usage of ZKP these days, besides using the layer 2 and privacy coins, is a project called Mina protocol. And the idea is that even if today we have a lot of projects aim to reduce the size of a block by offloading the layer 1, so either by aggregating transactions in layer 2 and submitting proof on layer 1, the fact is that the blockchain will grow indefinitely. Blocks are added one after the other, so that's why they form a chain, and it's called a blockchain. But at the end of the day, these blocks are never removed, and if you are a participant who comes later and tries to reconstruct the official state of the coin, so tries to reconstruct the actual balances of every account, for example, you would have to read the entire blockchain, and you would have to execute step by step all the transactions, everything that has happened from the inception of the blockchain, of the coin, from the first block essentially. And as time goes by, the blockchain grows, of course, and now you have hundreds of gigabytes, and there's a concern that this growth will not make it sustainable eventually. So the idea of this project is to actually use ZKP in order to prove that the history that led to the current block exists. So that's a very interesting twist on zero knowledge proof. Here, the hidden information is actually all the blocks that have happened before the current block. So that makes the current block or the current blockchain of a fixed size. So again, here I'm trying to explain again the idea. The block, normally you have a lot of blocks to form the blockchain, and each of these blocks contains some verification proof. So it's the proof of work or proof of stake that makes it that the current block that you see is valid and chained properly with the previous block. In order to make the whole chain valid, you would typically go from the first block that you have hard-coded, you know the first block, and then you verify that the chain goes properly, that block n plus 1 is actually really following block n. And to have that verification possible, you need all these blocks from 0 to current block. But with this idea, this Mina protocol zero-knowledge proof, we are saying that there is this history of blocks from block 0 to block n, and this history is the private information, the information that you don't have to show, such as the current block n plus 1 is really following the other blocks from 0 to n. So this is very interesting because this is a for example where you have the zero-knowledge proof, because the block itself contains the zero-knowledge proof, that is then used to be the input of the next zero-knowledge proof, because the block n, now the latest block, which contains the zero-knowledge proof, will be used as an input to produce the next zero-knowledge proof. It's well, these kind of functions that call themselves are called recursive, and this is the first production usage of a recursive zero-knowledge proof. So here you have it, a few examples of applications of zero-knowledge proof in production. These are the ones that I know about. Mainly, currently, it's about layer 2 on Ethereum, because the congestion on Ethereum makes it very difficult to use right now, and this is a problem that many teams are trying to solve. ZK proof are not the only way to do it. There's another design called optimistic rollups, but there are really only two competing designs. And also we solve some applications on layer 1, so privacy coins essentially, and Mina protocol. I'm not aware of other projects that are using ZKP at the moment, but I'm sure that the field will get more and more popular. Again, we are still in the early days, and there are a lot of technical issues still associated with ZKPs, which makes the development of practical applications a bit difficult at this point.